do practice problem number 7 on page 284. Let me read the problem. A 200-gram sample of water at 80 degrees Celsius is mixed with 200 grams of water at 10 degrees Celsius. Assume no heat loss to the surroundings. What is the final temperature of the mixture? So here's the warm water. We're going to pour it and mix it with the cool water, and we want to know what's the final temperature. And it also says that this is an isolated system in that we are not allowing any heat from the environment to leak in, and we're not letting any heat leak out into the surrounding environment. So it's a little bit of a contrived situation. Of course, anytime you have hot and cold liquids, you're holding them in your hands, you're in the environment, and a little bit of heat can leak out or leak in. But if you do it quickly, the amount of heat that leaks in or out is very, very tiny, and you can ignore it. So this is a perfectly valid problem if you think if you do it over a very short period of time. So let's solve the problem. We have the heat leaving the hot water. I'll call it H, and we have heat entering the cold water. I'll call that C, or cool water. I'll call it C for cool. And when I add the heat that's left the hot water and the heat that's entered the cold water, I get 0. Now, why do I say that it's equal to 0? Because the problem said that there's no overall heat lost or gained to the surroundings, which means that while the hot water is going to lose heat, the cold water is going to gain heat. Overall, there's no gain or loss of thermal energy in this system. So thermal energy will be conserved in this problem, so there's no net change. So this is going to be MC delta T. That is, the hot water is going to have a change in temperature, plus MC delta T for the cold water. So I'll just put a subscript H and a subscript of cool, and that's going to be equal to 0. Now, the nice thing about this problem, this particular problem, as opposed to ones that you might have on an exam, this is almost too simple for what I would put on an exam. The mass of the hot water and the mass of the cold water are the same. So I can divide by the mass, and it will go away. Divide both sides by the mass. And also, this is water and this is water. So the hot water and the cold water have the same specific heat capacity. There's both liquid water. So I can divide both sides by C, and that goes away. And so we have delta T for the hot water plus delta T for the cold water equals 0. And again, don't write this equation down as a basic equation on your equation list. This only works if it's the same stuff and you have the same amount of the same stuff, okay, mixed together. Very rarely will you get a problem that works out this easily. So this is T final minus T initial for the hot water minus T final, or I'm sorry, plus T final minus T initial for the cold water, and that will be equal to 0. Now they're going to end up at the same, so I'm going to put this for the hot water and this for the cold water. These guys are the same. They're going to end up, the final temperature is going to be the final temperature for all of the water. So this and this will be the same. So I can just add them together, and I get 2 times the final temperature. And then here, I'm going to add both of these to the other side. We have the initial temperature of the hot water. I'll put it on the other side, and now I'll just put in the numbers. And then over here, that's the initial temperature of the hot water. The initial temperature of the cold water is 10 degrees. And now I can just divide both sides by 2. And I get the final temperature is equal to 90 degrees Celsius divided by 2. So the final temperature is 45 degrees Celsius. Okay. Now, some of you started the problem too late, like you started by adding and dividing by 2. So even if you got the right answer, I want you to justify it from a basic equation. So make sure you show all your work and you show it with units and it all makes sense. Any questions on this problem? Yes?
What happens if you come across a problem where you need to, where it's like, you said like for number 8, where you have
if you have different masses and different heat capacities, you can't cancel them out. You have to solve the problem, and what? You don't have to remember any of the specific heat capacities or heat of fusion or heat of vaporization, because that will be provided for you on the exam. Okay, that is all.